Thank you. Well, it's wonderful to be here. As Mike McCormick in his very energetic, as always way mentioned, these are the very early results, but we're very excited about them. We've done something very different, and we would like to get you involved in any way that you're interested. My task, it's an easy one for me, is to talk about why ice cores are so wonderful and what we have been able to do with them. Ice cores provide us with, obviously, records that up until now have gone back to about 850,000 years. With my colleague, two colleagues, Nikki and Andre, we now have records that go back 1 million years. But we've also looked at very, very detailed recent records that go back a few thousand years. And this is where Colnifetti comes in. We have the ability to look, as you'll find out, right down to storm level, even in very, very old portions of the record, and to take this back a long period in time. As you can see, there are a lot of different proxies, and these are proxies for climate that we can examine. We've been able to calibrate many of these using meteorological records, including filtered, effectively, massage climate reanalyses of all sorts. And we've come up with strong calibrations in the case of Greenland for pressure features like the Icelandic low. We do this because we're able to track air masses, and we do it because we've developed some new software that allows us to fiddle with a lot of these climate reanalyses. Here in this really beautiful NASA Reconstructing, where they've colored existing data, you can see in this light blue sea salt in the Southern Ocean, and the north, the white is sulfate coming off anthropogenic sources, green, biomass burning, et cetera. And you can see that these are a mechanism by which you can fingerprint air masses. Now imagine that you have 60 or 70 measurements that you can use to do this, and this is the way in which we have been able to track air masses all over the world, as indicated by this idealized map. That shows you sort of just a several-day sequence of changes in atmospheric circulation patterns, dominated in this particular case by the westerlies. Why do we care about air masses? Because air masses transport heat, precipitation, and pollutants. And this turns out to be a very, very important story if you think about what you can do if, in fact, you have records on a seasonal, annual, and going back tens of thousands of years of how atmospheric circulation has changed. You can do what we did, which was to demonstrate, verify, and understand the behavior of atmospheric circulation in terms of abrupt climate change. You can look at how acid rain, the human component of acid rain, how far it goes, where it comes from. You can look at transport of lead off regions that had lead abatement long after we did. You can look at uranium coming off Australia and polluting by 2 orders of magnitude the Antarctic Peninsula. You can look at, can't see them from here. Oh, come on, here we go. Water resources. We're working in Chile, looking at how glaciers are changing. You can look at drought, Arctic warming, on and on and on. We don't need to worry about the details. If you understand how the atmosphere has changed over time and can label it, you can do a great deal. So, 10 years ago, because of Mike McElroy, Mike McCormick and I met. We started talking about how we could combine this extremely powerful historical record that's way better dated than the ice core record, and we decided the best place to do this would be Europe, because this, of course, is very close to where the historical records come from. So we needed an ice core from Europe. Many people had sampled ice cores in Europe before. Turns out that Colnifetti, because of its location, provides the best preserved record. As you can see on the right, several records come from Colnifetti. So why, in fact, would we re-drill this record? We re-drilled this record because existing Colnifetti cores only went back year by year, could be counted year by year, 200 to 300 years. Using new laser technology, we were able to do something quite different. The example here is the Greenland Ice Sheet 2 record, from which we demonstrated, verified the existence of climate change events. For 110,000 years, we had about 16,500 samples. Now, with the advent of laser ablation, we can, for example, at several hundred meters down at the transition between the last big abrupt climate change of the glacial period and the Holocene, where layers are 1 centimeter and 3 centimeters thick, we can now get between 500 and 1,500 samples per year. That means that we could extend back in time the Colnafetti record if we got a new one. So we went and we got that record. We've subjected it to this absolute dramatic change in the ability to analyze records at orders of magnitude higher resolution. We did this because of a generous grant from Arcadia given to Mike McCormick and the rest of us. And from here, I'll turn it on so that you can hear about the details.